Welcome to our 7th video in our unit on data analysis. If you haven't already watched the 6th video, the Introduction to Dimensional Analysis video concerning conversion factors, please go and watch that video before proceeding with this video. In this video, we're going to look at the process of solving problems using dimensional analysis. This is going to be a major problem-solving technique. And dimensional analysis, as I mentioned before, is also sometimes called the factor label method. And in this case, what we're going to be doing in all cases is rearranging or using units and labels to cancel out so that we can obtain a final result from a starting number. This method sets up conversion factors, which we covered in the previous version, so the units are canceled out, and we saw that in the previous video. In this unit, and as we move forward, you must set up your problem as we show you here to get full credit. Even though the final answer is important, what we're really more interested in here is looking at the process of solving the problem. So you must solve the problem, you must use the process, you must show your work, you must show the setup. So all work leading up to the final answer must be shown, including units on every number, and at the very end you must follow the significant figures rules as we saw them in a couple of videos ago. Alright, so what is the process? Here are some 8 easy steps. I'll go through them here and then we'll take a look on the next slide. We'll start applying them. So the first thing you're going to do is set up your starting equality. That's going to include the units that you're given and the units that you're looking for. We're going to list conversion factors that are going to tie our starting units to our ending units. And we're going to start the dimensional analysis with the value opposite the question mark. You'll see there's a question mark. The value is always going to be your starting number. Always start with the number that you're given. We'll set up the conversion factors so the units crisscross from each other. The units are set up opposite each other in the numerator and the denominator so that they'll later cancel out. We'll cancel out the units. Then we're going to multiply and divide through the calculation using what I call the zigzag method. I'll show you how this works, but be careful when plugging this into your calculator. Finally, we have to express the answer in the same number of significant figures as were given in the original starting value. Thankfully, the conversion factors do not count towards significant figures because if you recall properly, these conversion factors have infinite number of significant figures. So they don't count towards the significant figures. And finally, make sure every number, as I said, with very few exceptions, must have a unit. No naked numbers, they get cold, they get lonely. We want to have units with every single number. Alright, so let's apply that method to solving this problem. I want you to convert 3.179 hours to minutes. So what we're going to do first is we're going to set up our starting equality. We have our 3.179 hours. This is our known quantity, so that goes on the right side of the equal sign. And I want you to start all of your problems with something that looks like this, a question mark next to the unit that we want to have as our final answer. The reason is you have to include units all along the way. The units are like a map. In other words, think about it this way. If you wanted to get to Chicago, you would want to think about how you're going to get there from New Jersey. And you probably wouldn't want to go through California because that's going to get you out of your way. But you know that if you go through Ohio, then you can get to Chicago pretty easily. So these are like a map. It's going to help you find your way from where you start to where you want to get. So in this case, we need a conversion factor, a map, that takes hours and converts it to minutes. Well, what do we know? What number do we know that connects hours to minutes? We know that 1 hour is equal to 60 minutes. So we have the only conversion factor we need because we have hours and minutes in our known and our unknown numbers. We have hours here and minutes here in our conversion factor, so we're ready to set up. So let's start with the value next to the question mark, as I said, set it up here. Now we're going to continue the calculation to the right here. This is merely our starting point. Our conversion factor is going to be multiplied. You're always multiplying by the conversion factor, but what you want to do is you want to recognize that since we have hours in the numerator, we want the conversion factor that has hours in the denominator, so it's going to cancel out. So when we set it up, we set up the first conversion factor, in this case the only one. We put hours in the numerator from our starting number, so the hours goes into the denominator. The hours from our conversion factor goes into the denominator down here. The other value, the minutes, 60 minutes, goes into the numerator. And what's going to happen here is that the units are going to cancel. So we have our hours canceling here and our hours canceling here. The reason we know we only need a one-step conversion is because when those hours cancel, our unit that's left over is the same as the unit that we're looking for. So once you get to the matching unit, what we can now do is multiply and divide by the zigzag method. And here's how that works. Start with your starting number. If there was something in the denominator, we'd have to come down, but there isn't. So we start with our starting number. We move across. Every time we move across, we multiply. And then we move down. Every time we move down, we divide. We're going to do that math. So we get 3.179 times 60 divided by 1. If you want to pause the video and plug that into your calculator, go ahead and do so. And when we get the result, we get a number of 190.74 in your calculator. Alright, now this is not our final result, however. There's two things we have to apply. First, we need to have the same number of significant figures as in our original starting value. Remember, those conversion factors have infinite sig figs. So let's take a look at our initial number. We have 1, 2, 3, 4 significant figures, so we have to round this to 4 significant figures. There's 1, 2, 3, 4. The 4 is below a 5, so the 7 rounds down. We have 190.7. And finally, we need to have the correct units with our answer. The correct units, those minutes were left over, so bring the units over here, and we are done. The last thing, and I want you to get into the practice of this as well, is please box in your answer. Put this nice box or circle or something around your answer so that when I am grading your test or your quiz or your lab, it makes it really easy for me to see where your answer is. Alright, now, some of you are going to want to use an alternate method of setting up these equations. It doesn't matter to me which one you use. This is called the railroad tracks method because it looks like as we set this across, we have these railroad tracks. And if we had more conversion factors, we'd have more vertical lines. In this case, we always have our starting number. So just like before, on the top line in our first box, we put our starting number. Here we have our first conversion factor. Just like before, the hours cancel out and leave us with minutes, and then the math is exactly the same. Zigzag method, start in the upper left, move to the right, move down, multiply and divide. The correct number of significant figures, 4 significant figures, and our final answer is the same, 190.7 minutes. In the first method, the math steps are clearer, and I prefer that method. You'll see me modeling that most of the time, but if it makes sense to you, like the second method, it takes up less space and it makes more sense to you, you can pick that one and use whichever method you like. Remember, the key here is that we're multiplying, and so when we multiply across, anytime we go to the right, we multiply by anything that's in the numerator, and if it's in the denominator, we're going to divide if the value is in the denominator. Now sometimes you won't be able to solve the problem in one step. You'll need more than one step. So unless you know the conversion factor for hours to seconds, then we're going to have to use two conversion factors because we know that there are 60 minutes in 1 hour, and there are 60 seconds in 1 minute. I don't want you to combine these two conversion factors unless you do so explicitly and show me the math that's showing me how you combine these. Instead, if you have a two-step conversion factor, I want you to do it the way I'm going to show you here. As before, we're going to start with our known value. Here's our 2.5 hours, and here's our unknown on the left next to the question mark. We want to have that final answer in seconds. Since we have hours here, we want to have hours in the denominator to cancel it out, and so we're going to go to our first conversion factor, 60 minutes in 1 hour, and put the minutes, 60 minutes right up there. Cancel out the hours, and now we have minutes. You notice, however, that minutes is not the same unit as what we're looking for, so that tells us that we must have at least one more conversion factor. Alright, so we leave the minutes here. Since we've got minutes in the numerator here, now we say, aha, I've got minutes here connected to seconds. That seconds is what I want as my final result, so that conversion factor is going to get me where I want to go. Put the minutes in the denominator, put the 60 seconds in the numerator. So the minutes will cancel out. When the minutes cancel out, remember the hours already canceled out. That leaves us with seconds as our final result. Seconds is what we want as our final answer, and so all we need to do now is the math. Let's go ahead and calculate the math using the zigzag method. We have 2.5 hours times 60 minutes. Sorry, forget about the minutes, that wasn't there. 2.5 times 60 divided by 1. In this case, yes, we are dividing by 1. Sometimes we will have a number other than 1 in the denominator. Multiply by 60 again and divide by 1, and we get our answer. Our answer is, well, our numerical answer is 9,000. So we have to do two more things. Remember, we need significant figures and we need our units. We have two significant figures here. We need two significant figures here. Now, you notice I have a problem here. I cannot indicate the correct number of zeros. If I put a decimal point here, then I have 4 significant figures. That doesn't work. The way I have the number written now, it's only one significant figure. So the only way to make these two numbers significant is convert this to scientific notation. Take the decimal point there, and we get 9.0 times 10 to the third. The 10 to the third still stays, but here's our two significant figures, and there's our unit seconds, and the answer is boxed in. By the railroad tracks method, we get exactly the same result, exactly the same setup. Again, some people may like this, and some people may prefer the conversion factor method. All right, let's do some practice. We have some funky units that we may use. Some of these units are real, some are made up. Look at the conversion factor table on your worksheet. I didn't have room to reproduce it here. Okay, so anytime we have an equality, remember we have a conversion factor. So if you look on your sheet, you'll see that there's an equality between hogsheads and firkins. And from that we get that one hogshead can be divided by 7 firkins for one conversion factor, or 7 firkins divided by 1 hogshead for a second conversion factor. Use that sort of a logic throughout these exercises. In our first example, we're going to find out how many moles of platinum there are in 1.9 times 10 to the 24th atoms of platinum. Now, we're going to cover the concept of moles in Chapter 11, which is coming up next, but for now, just realize that moles and atoms are two units that can be related. Here's our starting point. We want to know how many moles of platinum are equal to 1.9 times 10 to the 24th atoms of platinum. Our conversion factor is that there is 1 mole equal to 6.022 times 10 to the 23rd atoms. So these are the two places we're going to start. You notice now we have the same starting and ending units here, moles and atoms, so we know we're only going to need one conversion factor. Start your conversion, start your process. 1.9 times 10 to the 24th atoms of platinum. In our conversion factor now, we want atoms to be in the denominator, so this number is going to end up in the denominator, and 1 mole is in the numerator. Put the atoms in the denominator, put the mole in the numerator. The atoms of platinum are going to cancel out. They're going to leave us with moles of platinum as our unit. And we get 3.2 moles of platinum. Two significant figures here because there's two significant figures here. Did you remember to use your EE key for scientific notation? If you obtained a value of 3.2 times 10 to the 46th, this is something you're going to watch out for a lot. Then you probably did not use your scientific notation key. All right? Remember, if you're taking a number of 10 to the 24th and you're dividing by 10 to the 23rd, the exponents subtract when you divide. So you should get something much, much less than the 10 to the 46th. All right, two more examples that we'll go through together before I let you go on your own. We have a typical air conditioner using about 9,000.0, notice the decimal point there, BTU or British thermal units of power in 1 hour. How many ergs is this? Well, we want to know how many ergs there are in 9,000 BTUs. If you look at your equation sheet, you'll see that there's no relationship, no equality that could directly connect ergs to BTUs. However, there are two conversions that you can see that will get you there. First thing we're going to do is we can connect BTUs to joules. We do that using 1 BTU is equal to 1,055 joules. J means joules. We'll learn more about that later on. Finally, to connect joules to ergs, we see that we have a conversion of 1 erg being equal to 1 times 10 to the minus 7 joules. So let's get things set up. Take our 9,000 BTUs. We're going to use our first conversion factor here. Since the BTU is where we're starting, the 1 BTUs is going to go into the denominator. So the BTUs goes down here. The joules goes up to the top. Our BTUs cancel, leaving us with units of joules. We need to cancel joules because we need to end up in ergs. So in the next conversion factor, joules is going to go into the denominator. Put the joules down into the denominator. Erg goes into the numerator. Cancel those joules. That leaves us with value of ergs. And then all we have to do is the multiplication and significant figures and units. Multiply 9,000 by 1,055. Divide that by 1. Multiply that by 1. And now here we have a unit in the denominator. Divide that by 1 times 10 to the minus 7. Don't forget to use that EE key instead of the 10 to the minus 7, right? EE key, otherwise you're going to get this wrong. We have 5 significant figures in our starting number, so we need 5 significant figures in our ending number, and our units are joules, our ergs, and so we get a final value of 9.4950 times 10 to the 13th ergs. Again, you need that 0 on the end to indicate 5 significant figures. Next example. Suppose you had a bushel of apples and it cost you 2.80 sops. Obviously, there's no real unit of sops. This is some funky made-up units. How many fots, if you only had fots, how many fots would you need to exchange to get 2.80 sops? So let's see what kind of conversions we need. We need to get from fots to sops. Again, there's no direct conversion from fots to sops. So what it turns out now is we need to do a 3-step conversion. We have one conversion that can get us from sops to tuz. All right. Once we have units of tuz, we can go from tuz to befs. And finally, from befs, we can get to fots. The process is going to be the same. Let's set this one up using the railroad tracks method this time. So we start off with, we put our unknown on the left side equals to our starting number. Always put the starting number first, 2.80 sops. In the conversion factor, sops are going to go in the denominator. So 2 sops in the denominator. We have 3 tuz in the numerator. The unit sops cancel out. Remember, only the units cancel out. The values do not. Now we have tuz. So in the next equation, the next conversion, tuz goes in the numerator and the denominator. Befs go in the numerator. Cross out tuzes. And in our last one, we go from befs. Befs goes in the denominator. We put 9 fots in the numerator. We cross out befs. Since our final unit here is fots, which is what we want. We're ready to go. So let's do our calculation. 2.80 times 3 divided by 2 times 4 divided by 3 times 9 divided by 2. Now you can really see why this is called the zigzag method, because I'm zigging and zagging between numerator and denominator. When I get done, I need 3 significant figures in my answer, and I need units of thought, and so I get 25.2 thought. Alright, I want you to try to solve the following problem. I have 24 panes. No, I'm not talking about you guys. I'm talking about just general panes I have. How many groans do I have if I have 24 panes? So I'm going to pause the video, restart it when you've solved the problem. Let's see how you did. I'm going to start off with our starting point. I want to know how many groans there are in 24 panes. Notice you can't get from panes to groans in one step. You have to go from panes to grunts first, then from grunts to groans. Our first conversion factor connects grunts to panes. There's 20 grunts in a single pane. And next we're going to see that there are 15 groans in every grunt. So now we have the connection between panes and groans. And here's our answer. Start off with 24 panes. Panes is in the numerator, so we put it into the denominator here. They cancel out here. Grunts goes on top, and there's 20, so we used our first conversion factor, 20 grunts over 1 pane here. Now we have units of grunt. We want units of groans, so what we're going to do is cancel out the grunts. The 1 grunt goes in the denominator here. The 15 groans goes into the numerator. The grunts cancel out. They leave us with groans as our unit that we want for our answer, so groans is the unit that we want. We have 2 significant figures in our starting number, so we do our math. 24 times 20 divided by 1 times 15 divided by 1 gives us 7,200 groans. Now you could use scientific notation. You don't have to here, but scientific notation will tell us that we have 7.2 times 10 to the third groans. Finally, if you want to see this using the railroad tracks method, some of you may have used that, here's what you're going to, your result is going to look like. Hopefully you have something that looks very much like this. Alright, so in class next we're going to take a look at solving problems using dimensional analysis. Please make sure that you have completed this worksheet, and if you have any questions, go back and look at the parts that are giving you problems. See you in class.